So in the previous lectures, we have discussed the importance of CAD-CAM in industry, role of computer in product design. Then we have discussed also the geometric modeling, techniques of geometric modeling, solid modeling, wireframe modeling, surface modeling, then transformation, 2D transformation, 3D transformation, all things we have discussed. And now we will go for the this CAM part, computer aided manufacturing, in which these NC machines, CNC machines play a major role. So we will go for NC machines first. So it is called numerical control manufacturing. So manufacturing process is controlled by the numerical data. Okay. So NC machine in the data is entered in the form of code in the form of punch step. So that is called NC manufacturing. So learning objectives, what we will discuss in this lecture: fundamentals of NC technology, advantage and disadvantage of NC manufacturing, components of NC machine tools, axis designation, principles of part programming, types of NC system, basics of computer assisted part programming, NC machining centers. Say introduction. What is numerical control? So numerical control is any programmable automation. Automation means all the things will be done by computer controlled machines. So that is programmable automation is called a numerical control. So machining steps of the part are captured in the form of a part program. NC machine tools are suitable when there is a variation in the work part configuration. Manufacturing systems can be classified as discrete part manufacturing system and continuous process manufacturing system. So you can see movement of manufacturing towards NC. So transfer lines, then seam, NC machine tools. So according to the part variety, in the NC machine tools, the variety of parts can be made on larger scale and part volume is less. Means if you want that a specific part, but the variety varying, so then we go for NC machines. So in NC machine tool, the following functions are made automatic: starting and stopping of the machine, speed control of a spindle, positioning and guiding the tool tip along the desired path by control of slide motions, feed rate control, and tool change as per requirements. So in NC machine tools, feed rate can be controlled, guiding of the tool and workpiece can be done easily, a spindle control can be done easily. Whenever there is any problem in the power or something, starting and stopping of the machine can be done in the this any mishappening takes place. We can change the tool as per the requirements in the NC machine also. So in the state of offline programming, the programs are prepared on a separate computer, that is called the computer numerical control. So direct numerical control on the other hand refers to use of mainframe computer controlling the several NC installations in the manufacturing plant. The NC systems are more expensive because they require a large memory system for storing programs and data. So basic structure of NC machine tool is machine control unit, machine tool to be controlled by the machine control unit, drive unit, servo control, feedback devices. These are the basic structure of the NC machine tool. So machine control unit, then machine tool, then drive units means a special drive for the workpiece table, then this spindle also, then servo control, positioning of the tool and workpiece, feedback devices for the maintaining accuracy of the machine. So there are 4 steps in a typical NC manufacturing process. First, we will model the part to be machined in the CAD environment. Then obtain the machining control commands, either cutter contact and its location data through a CAM system. Convert the cutter location data into G codes. Load the G codes into N system and implement the NC machining of the part. So first, whatever we design, we have to make the part. First, we will design in the engineering drawing part in the software. Then we will process planning. Then we will write the part programming. We will write the codes of the machining after locating the tool and this cutter and the workpiece. So after getting the G codes and M codes that require part programming, we implement the NC machining of the part. So process planning is a process of listing manufacturing instructions for various machines to produce the finished part. Suppose it means when you draw something in drawing, then after that we plan that which manufacturing process will be used and which part to be used for which machine. So there are 3 processes to complete this process, like manual approach, then computer assisted variant approach, computerized generative approach. So there are two levels of process planning system: high level planning and low level planning. So what are the principal axis of motion in these CNC machines? So to plan the sequence of positions and movements of tool with respect to the workpiece, it is important to establish a standard axis system. So most existing machine tools use right hand Cartesian coordinate system. So in the diagram you can see right hand system, thumb represents the x-axis, then second finger represents y-axis, and the rest finger represent the z-axis. So Z, there are different these three axes, and if you take the negative and positive directions, so there will be 6 directions. So most existing machine tools use right hand coordinate systems. So first is diagram is for right hand coordinates for milling table for then turning workpiece XYZ and XYZ coordinates for the milling table. Then a specification of origin of coordinate system. So a part programmer can use the two methods for identifying the origin of system. So they are fixed zero method and floating zero method. So fixed zero means origin. Origin is fixed with respect to origin absolute system, and floating zero means the origin changes from a step to a step. That is the incremental system. So coordinate system in the CNC machine works on the two things: absolute system and coordinates and incremental system. So a part programmer can use the two methods. In the fixed zero method, the zero point is always situated at a fixed location on the machine table. In the floating zero method, the part programmer decides the location of the 0 point anywhere according to the convenience. So what are the modes of numerical control programming? Already I have told it got coordinate system, absolute mode, incremental mode. If you will see in the final absolute system, all the dimension of this part is made with respect to 0, 0. Absolute means origin point, original origin. So you can see the original dimension of the second the 600, then this with respect to 150, then with respect to the initial origin 400, 250, 400. You can see all the systems are made in the absolute system. Means all the dimensions are made with respect to the 0, 0 original origin. But if you go in the second diagram incremental system of dimension, you can see the origin changes. Means 0, 0. Then you go for next point, then the previous point will be the 0, 0. That means the origin changes from a step to a step. For the third point coordinate, the origin will be the location of the second point. Okay, so the origin changes from a step to a step. Now motion control system in numerical control machine tools. So there are three basic types of motion control system in NC machines. First is point to point system, then a straight cut system, then contouring or continuous path system. So in first diagram you can see path of motion point to point here. So that the how the system is achieving from initial point to final point, that path is not taken into consideration. So only initial and final points are taken into consideration. So that is called point to point systems. Like drilling. So drilling means you are drilling the machine to drilling the part at a specified location. That is point to point system. So path of motion is not important. Only initial and final point to point. So point to point system is there. If you go in second a straight cut system, like turning, step turning. So you are doing the straight turning, then again one step, then next step. In the third diagram you can see continuous path, means milling like system, contouring system. You are starting the work to be done, and it is an ongoing process. Continuous path cycle is going on. So contouring or continuous path system like milling process is there. So that is contouring or continuous path system is there. Then feedback devices and servo control system. So feedback devices are used to maintain the accuracy and adaptability of the machine tools. So at each step, the feedback is taken. Then what is the error? Where is the error? Then we rectify it. So feedback devices are termed as sensor and transducers are there. So there are two types of transducer, analog and digital. Two types of servo control systems in NC literature: open loop system and closed loop system. In open loop system, there is no system of feedback, but in closed loop system, there is system of feedback. So whatever feedback you receive, then you accordingly modify the system. Then applications of numerical control. So NC machine is the most appropriate under the following conditions: when machining components of high accuracy is required, then machining components when undergo frequent design changes, So like this, if there is high accuracy required, then we go for NC machines. If under frequent design changes is required, such components, then we go for the NC machine. When it involves repeating production of precision parts in a small and medium lot sizes, then we go for numerical control. Several operations on a component. In a single component, number of operations are there, so that we go for NC machines. Then complex geometry are there, then we go for the NC machine. So NC machine is capable to produce the high accuracy parts. Then if the requirement of sudden change in design, also complex design, multiple operations, precision parts on larger scale and as medium scale, then we go for numerical control. So advantage of NC machines are that there is increased productivity due to reduced setup and lead times. So if you are carrying the process by NC machines, then lead time will be reduced. Means setup machine, setup of tools, machine tools and table like this time will reduce. So accordingly productivity will increase. Then there is reduction in the scrap, loss and wastage of the this materials is reduced in the case of NC machines. Because in the manual human errors are there, so that's why we go for the NC machines. So the increased rate of production also due to high reduction in non-machining times. So there is high accuracy leading to interchangeable use of components. Since there is high accuracy, so we can interchange the components according to requirements, certain design changes. So better quality control is also possible in case of NC machines. But the disadvantage is that it requires high initial investment. Then for maintaining and fair operation, we require skilled labors also. For part programming also skill labor required. High investment for maintenance also, breakdown also. So cost of programming becomes high. So that is a disadvantage of the NC machine tools. Then types of numerical controls. Simple manual NC systems, then CNC system, then DNC system. In a manual system, whatever there, so we write the command, then in the NC system we use the punch tape to enter the commands and enter the punch tape into the machine manually. But in case of the CNC machine tools, there is no need of punch tape. We write the command in the this computer, or we generate the drawing, then we go for the code generation. In the NC system, all the things are controlled by central computer on the shop floor. So that is the DNC systems. The machining center. Machining center is the actual place where the machining is taking place. Okay. So it is a machine tool which can perform several different operations in a single setting and can automatically change the tools while being under programmable control. So this is the diagram showing vertical milling center, CNC machine. Features of machining center is that like conventional machine tools, a machining center has the following principal components: bed, then saddle, then column, tool changer, spindle, servo system, machine control unit, and table. So in the CNC machine, there is 5-axis machining center. Then x-axis is controlled by the saddle, linear movement. Then column gives the y-axis, z-axis gives the table, given by the table. A-axis controlling and tilting by a spindle, B-axis rotary table. So these 5 things axis machining center is controlled by different components. So these are the features of machining center. So there are 2 common types of turning centers in use: CNC checking center and CNC turning center. NC programming. NC machines operate according to the received code instruction. Generally, word tape format is used to indicate the arrangement and order of coded instruction. So the commonly used words in the order of block is N word. We denote the sequence number to identify the block. So the complete word usually consists of 3 digits with N as a prefix, means N001, N002. So that represents the block table. So G word, this is also called preparatory word, used to prepare the controlling unit for operating functions. Say some examples of the preparatory codes, G words like G00, G23, G19, all things are there. Preparatory codes for the starting function of the machine they are required. Then F words comes for a feed rate, then S words comes for a spindle speed, T words come for tool number, which tool is used, drilling tool, milling tool like this. M words are miscellaneous function for controlling of the machines like a spindle stop, coolant on, off, program stop like this. So these are some of the examples of the M codes. So this is example of some turning example, how the program is written in G1 block number, then G codes, then G code, then M code like this, then a spindle speed, F, then feed speed, then this coordinate system. So these things are given. So you can see the example of this turning example. So CNC control programming language, many part programming language system have been developed to perform automatic calculations. This saves a lot of time and also results in more accurate, efficient part of programs. So various stages in computer-assisted program, APT program, then computer computer operations, then constitute the machine tool. So in CAPP, machining instructions are written in English like a statement of NC programming language. Some popular and powerful part programming languages are APT, automatically prompt tools, adapt, exapt, iniapt, miniapt, split, prompt. There are 4 types of statements in APT language: geometry statement, motion statement, post-processor statement, auxiliary statements. Sensi machines. So what we have discussed in this lecture, sensi machines which accessory devices such as inspecting system are often called machining centers. So but addressable formats for programming are most commonly used. Machining and turning center provide means to complete all activity including machining, inspection and sorting at a given layout. So APTY is the product of MRT development work on NC programming systems. So they are the references. Thank you. Thank you for your patient listening. Thanks a lot.